Okay, we're going to start this video. We're assuming that you have a little bit of prior knowledge about similar triangles. Just quick review. To be similar, just similar anything, you got to have the same shape but different size. Now, today we're talking about similar triangles only, but the same shape is telling you that the angles have to be the same. The different size, as far as similar, the sides have to be proportional. So again, we're kind of assuming you've already had a little prior knowledge based on that. Okay, and then there's three theorems that go along with that. Here's your three triangle similarity theorems. Now you'll recognize this side from where we did congruent triangles, but this is different. Congruent triangles, side meant all three sides were the same. Side, and similarity means all three sides are proportional. All right, and then side angle side, that will be familiar from congruent triangles as well. But again, sides have to be proportional and angles have to be the same. All right, but the one that's probably new is this AA. So what you have to have in order to be similar, all angles have to be the same. So here's an example of an AA theorem. So if I have this, first thing you should recognize is I have vertical angles. So this should be labeled, as soon as I see this, I know that those two angles are the same. So this one's 35, that means this one would also be 35. And if you see the other ones, all right, I got 30 and 115, obviously not the same, but I can find E, and now I could find A, because I know C right here is 35. Let's go ahead and find E. We know a triangle has to add up to 180. So if I take 35 and 30, that is 65. Okay, and I'm going to go 180 minus that. And I get 115, which is the same as angle R. So the reason it's just AA is because if two are the same, the third has to be. And again, to be similar, all the angles have to be the same. So that's why it's not AAA, it's just AA. So there's an example of that one. Side. Again, here's an example. The sides have to be proportional. All right, so if you match up these sides, again, a little prior knowledge is expected. So 3, right, the smaller side in this small triangle is going to match up with 4.5, which is the smaller side in this one. 4 is going to match up with 6, and 5 is going to match up with 7.5. So if I set up those ratios, in this example, they reduced the fractions. The fractions, all three reduced to 2/3. That means those are proportional. So side would be a shortcut. And then this one that's not used very often is this side angle side. So the included angle. If you remember congruent, side angle side meant that they're the same. So again, side angle side, sides have to be proportional. Included angle, because again, A is in between the two S's, has to be the same. So in this example, the 55 is included between these two sides. This 55 is included between those two sides. So if the corresponding sides are proportional with an included angle, then they are similar based on this side angle side. So we'll go ahead and do this. 15 is the smaller of the two. That would go with 18. So 15 over 18. And again, if you're good at fractions, you can just reduce that to 5 over 6. But if you'd rather just put it in a calculator, I get 0.83, which means 20 over 24. Those two match up. Better be 0.83, but again, if you're good at fractions, you can go ahead and reduce that. That would also reduce to 5 over 6. But you see the two decimals are the same, so that means sides are proportional. And that's a side angle side example. So these are the three theorems we're going to use to see if these things are similar. These triangles are similar. Okay, here's an example of what we're going to be talking about today. The question is, are any of these triangles similar? So if I look at this big picture, you can see where this big triangle ABC and this red, which is called an altitude, this is a big right angle right here. So the big triangle is a right triangle. And this red is an altitude to the hypotenuse, because the side opposite the 90 is called the hypotenuse. So this is an altitude to the hypotenuse, because altitude, that's your 90 degrees. Okay, so here's what the whole idea is about. What we're going to do is we're going to take each of the smaller triangles and separate them out. So this triangle is going to be this one. So we're just going to kind of draw that and take it out so we can look at these as individual triangles. I think that would be easier. So if we take that, right, A matches up and D is your 90-degree angle and B, we're just going to take that out. We're going to take the other one, which is DBC. You can see that matches up. We're going to just take that out and put it over here too. So we can just look at this as three separate triangles. I think that would be easier. So the question is, which ones are similar? So let's take the big triangle, right, ABC, and compare it to the smaller triangle, which is this red one. All right, so what you see is angle B is your 90-degree angle in the big one, and angle D is your 90-degree angle in the smaller one. Again, that's the altitude, so if this one's 90, the other one has to be 90. That goes back to lines have to be 180 degrees. Okay, but what you also see is this angle A in the big one has got to be the same as this angle A in the small one. It's the same angle. So now that I have two angles that are the same, then I can go ahead and say those are similar. That's the AA theorem. So the big one is similar to the small one. Right? We've proven that. So let's take the big one and compare it to the medium one. Okay, again, the big one, angle B, is 90 degrees. The medium one, D, is 90 degrees. So I got one angle the same. But again, if you look at C and the big one, whatever that is, it's got to be the same as C in the medium one. So again, two angles the same, the third has to be. So that would be similar to the big one as well because of AA. All right, and back in algebra, you learned we got to put these in order. So what would it be? Okay, so these are our potential answers of what it would be. So this says ABC. So ABC in the big one, right? B being your 90-degree angle. Which one of these would it be? I've kind of already given you a hint. D is the 90 degrees, so D has to match up with B in the big one. So you see B is in the middle, so D has to be in the middle. So the only two that make sense right now are those two. And angle A in the big one has to match up with angle A in the small one. So that's why it has to be that one. So triangle ABC similar to triangle ADB. Again, order is important. Make sure the corresponding parts match up. Okay, then I have, we said the big one's also similar to the medium one. So B is the 90-degree angle in the big one. D is the 90-degree angle in the medium one. So those have to match up. So B and D have to be in the same spot. So that means I'm either here or there. Okay, again, angle C in the big one has to match up with angle C in the medium one. That's the same thing, which tells you that this is my statement. So here's what I have. ADB, right? ABC is similar to ADB, the smaller one. ABC is also similar to BDC in the medium one. So the property in algebra says if that is true, then the small one is also similar to the medium one. And that's the idea that we're going to use today. Okay, so the statement is telling you that the altitude to the hypotenuse, right, in this example is ST, divides a triangle into two triangles that are similar, the smaller one and the medium one, which also means they're similar to each other. All right, so this is just an example of what we just did. So let's use this statement right here and help us with these problems. So we're going to label these the same just to make it simple. This example is QRS. That would be similar to QST, which is similar to SRT. So that's the same idea of what we just did. So what we're going to have to do now, knowing those are similar triangles, this asks us to solve for X. So you see X is QS. Okay, so go back to the idea that in order to be similar, sides have to be proportional. So if that is true, this statement has to be true. So if I take the big one, compare it to the smaller one, QR has to match up with QS. QR, the first two letters, and QS, the first two letters of the smaller one. RS, second and third, has to match up with ST, and QS, first and last, has to match up with QT. So what has to happen to be similar? Again, sides have to be proportional. So these ratios are going to have to be the same. All right, that's true, then let's plug in what we know. If you plug in what we know, this is what you get. All right, QR is this 6 plus that 14, because QR is the whole length of the hypotenuse. So that's where 20 comes from. QS is X, which is what we're trying to find. We don't know RS, and right now we don't know ST, so we're really not going to use that ratio. But we do know QS is the X, and we do know QT is 6, which is here. So we're going to use the first ratio and this last ratio to solve for X. So look what happens when we do that. Here's the setup. All right, again, this is proportions. A lot of people call it the butterfly, whatever. Anyway, you cross multiply is what you do. So X times X gives you X squared. 20 times 6 gives you 120. Square root both sides, and we get the square root of 120. Now, that can be broken down. Back in algebra, you talked about how to break square roots down. We're not going to do that. We're just going to leave it the square root of 120. If you want to put it in the calculator, you can put it in the calculator to get the decimal value. But for right now, we're going to leave that like that. Okay, then it asks you to solve for y. Now, what you got to do with this is you got to figure out what I know, what I don't know, and figure out what two triangles am I using. So in this example, getting y, am I using the medium one and the small one and comparing them? Am I using the medium one and the big one to compare them? That's what you might have to look at. All right, so what you find out when you do that is you're comparing the small one, because that has y in it as well, to the medium one, which also has y. Okay, so that's what we're doing on this one. If that's true, then your ratios should match up. So this is a different set of ratios. So again, QS, this is the statement. QS, first two similar to or over SR, those match up. ST's first or second and third letter matches up with RT, that's this ratio. And then QT, first and third, matches up with ST, which is first and third there. So those ratios have to be the same. They're the same, that means that these sides are proportional. And if that's true, then they are similar. So plug in what you know. Okay, we don't know SR. We do know X because we already solved for it. But for this one, we're going to be using these last two ratios. Set up the proportion. And just like over here, you're going to cross multiply. So when you cross multiply, you get y times y. That's y squared. And 6 times 14 is 84. Take square root. That's the square root of 84. Again, that can be broken down too, just like the square root of 120, but we're going to leave that like it is. Okay, so now what I want you to do is pause the video and let's try this number 3. A little different, but I want you to try it using the same similar statement we did at the first. So all you have to do is use this, apply it to this one. So set up your ratios, figure out which ones you're comparing to, set up your ratios, and solve it. So go ahead and pause the video and let's try number 3. Okay, so I'm assuming you have tried number 3, and let's see how we did. This is what you should get. So to get x, again, x is this QS, you're using the big one and the small one. So once you plug in what you know, you're using this first ratio and this last ratio. Cross multiply and take square root. That's the square root of 10. Again, you can get the decimal of that, but we're going to leave it square root of 10. And what you're going to find out to get y, you're going to use the big one along with this medium-sized one, because the medium-sized one is what has y in it as well. So when you set up those ratios, the big one and the medium-sized one were QR, right, first two with SR, RS, second and third with RT, and then QS and ST, then plug in what you know. We're using these first two ratios because we don't know what ST is. So using those first two ratios, cross multiply, square root, that's the square root of 90. That can also be broken down, but don't worry about it as far as now. All right, so that's an example, 2 examples actually, of this altitude similar triangles idea. So the altitude of the hypotenuse of the right triangle divides the triangle into 2 triangles that are similar to the original, which means they're similar to each other, which just means this statement right here. So hopefully that helps on your future assignments, but also your test coming up.